So let me start by thanking everybody who's been involved in the making of the Valkey Deb. And thanks to Maddie for the first presentation, because then I can safely go into my presentation, because I'm not a Valkey expert. I won't be talking much about Valkey itself, but rather how we have onboarded your work, the Valkey, the upstream Deb, into Ubuntu, and how we are using it for containers and Kubernetes environments. So my name is Cristovao. Don't try the whole thing. It's quite a tricky name to say. Myself, I even don't write my own accents anymore, so just call me Chris. I'm in charge of a team at Canonical who's doing mostly containers, so all the Ubuntu-based containers and the new initiative of container technologies that we are doing around distros and also the declarative builds. That's what me and my team are doing. So I'm a bit biased on that topic. I'll be talking a bit more about that later in the presentation, and I also have a demo for you, so that will be the last thing, so we can talk about it later. To start with, I will try to set the ground points by talking a bit about open source and the Ubuntu community and how the Valkey comes into place and how we have onboarded it into Ubuntu. I'm sure some of you have seen this, other people might not, but there is a very interesting report. There's the link down there, you can easily find it on Google, but this is a report about the state of open source in general, and it was a big survey about how people use open source software, why they use it, what are the challenges, what are the hot topics around open source. And one of the interesting things that this report is showing is that, as expected, most organizations are using open source because of costs, like money moves the world, and because of the licensing terms or no licenses at all and no cost there, people just like to use open source. And of course, on the other side, the challenges there is because there is sometimes some struggle to find the right maintenance, to get the right support, to drive the right intent behind the open source, because since there's no specific financial intent, sometimes some companies might want to target and tailor the software to their needs, which might be tricky if you are using an open community to drive your innovation there. So those are some of the challenges there. And part of this survey also showed what is the most used Linux OS around global organizations. And well, here I'm proud to say Ubuntu came as the first one there. And this is something that is published by Canonical. I'm sure you knew that already. If you didn't, now you know. And it's not surprising to me because I knew it before joining Canonical, and now I know more about it. But the terms LTS that were pioneered by Canonical for Ubuntu, long-term support, and a very predictable release cadence that is based on upstream and open source, these are the things that make people trust Ubuntu. And some of the numbers that actually go along that statistic about being the most used Linux OS are showed here in the fact that across the whole computing spectrum, we can see that Ubuntu takes a large beat and a large presence from cloud to the edge. Ubuntu is the most used OpenStack OS for the OpenStack nodes. On containers, for example, Ubuntu has more than 1 billion downloads from Docker Hub. And we also have special flavors of Ubuntu, like Ubuntu Core, which is specific for the edge. So there are some numbers there that are not from this year, but from a couple of years ago, but that are still relevant. But this is like I like to call this the perfect modernization story, because what this means is that Ubuntu is the same across the entire computing spectrum. If you are working on the cloud with some Linux application in Ubuntu, you are guaranteed that that dev or snap or Ubuntu container will work the same way for a Kubernetes or a container as a service environment, or the same way for an edge computing node, because it's still the same Ubuntu bits, it's still the same software. The packages that you are installing have the same digest and checksum, so it's literally the same thing, so it's very easy to move from one area to the other of the spectrum. Now, starting to move a bit more into data technologies, one of the things the survey shows here is that databases and data technologies are the techs with the most investment in open source. And that kind of leads us to, well, in this case, it was still Redis here, but kind of makes a point that right at the very, amongst the top most used data technologies globally by organizations, we have Redis. And on the right side, again, the challenges of adopting those data technologies from open source are again about keeping up with updates, maintenance. How do you install? How do you upgrade? How do you configure? Once things go end of life, what then? So this brings us to the onboarding of Valkey for Ubuntu users. So again, thank you everybody who worked on the Valkey Debian package. Basically for Ubuntu, we have onboarded the upstream Debian package, and it is now available in what we call the Ubuntu Universe repository. So at the bottom part of the slide, you can see that this is our typical release cycle diagram. The aubergine rectangle for each Ubuntu release represents our universe repository in the sense that these are packages, and those are, maybe someone can correct me, I think it's 30,000 plus on average per release that we have there, that are freely available for everybody. And you also have the option to opt in into our enterprise offering to get also security updates for 10 plus years. So regardless of the release you are working on, if it's not an interim release, you can get those for free plus security updates if you opt in to have that. And Valkey is there. Valkey is on the aubergine rectangle, so it's part of Universe. You can get it today on 24.10, and you'll be able to get it as well on 24.04, starting from mid-October. Now, I'm going to talk about the 3 different ways we are delivering Valkey for Ubuntu users. Starting with the deb, which is, again, the majority of you have worked on it, so I don't really have much to add there. I think you know pretty much how it works. We are onboarding and building the Valkey Ubuntu Debian package for multiple architectures. This is done automatically through our Launchpad build farm. We have it today on 24.10. We have done it for Valkey 7 and not 8. And you might be asking the reason for this, why not 8? So it's twofold. First, every time we introduce something, a new software into an Ubuntu release, we have to do it in advance. There's an average time frame of 3 months in advance. And in this case, with Valkey 7, we are able to backport this into 24.04 and introduce it to 24.10 because it's kind of a drop-in replacement for Redis. But since Valkey 8 already has a feature diff, that would need to go in advance with proper coordination. So the plan is that it will be there for 25.04, starting from a few months from now. The Devo release will kick, and then in spring next year, you'll get it officially in our next interim release. So for 24.04, you should expect it to be there in Universe as well, starting mid-October. And this is basically how you get it. Like, I'm sure as well that you know how to get it, so just apt install the same way you would do it on any other Debian system. Now let's talk through the snap. We have also packaged this as a snap. And for those who don't know what a snap is, this is basically just a sort of sandboxed environment. So what's happening here is that the snap, taken from the Debian package or its source, eventually it's going to be the same thing. It's going to be packaged in a sandboxed environment, and all of its dependencies go inside that package, that snap. Once you install that snap on your Ubuntu system, you'll get automatic updates because there is a snap daemon running inside. And this is an ideal delivery format for systems like IoT and edge computers. You can find the Valkey snap on the Snap Store. Right now, it's still unlisted, meaning that if you just go to the web interface and look for it, you might not find it unless you have the URL there. And this is because right now, we work on a risk-based delivery process. Right now, the Valkey snap is still in Edge, so it's not stable yet. Once it's stable, it will be listed there, so you can find it. And this is how we would install it from a snap, especially if you are using Ubuntu Core, for example, which is fully snap-based. This is how we would get it. And if you are wondering about the charm prefix, now, this is just a let's say, a legacy reason. It's a typical choice that we do for many of our snaps, especially if those are going to be working with our charmed operator framework. It will most likely be removed in the future just to be called Valkey, because the software can live standalone by itself and not necessarily be coupled with a charmed operator. So you will most likely see it be called Valkey in the Snap Store once it becomes stable. Now, this is the closest one to me, so I'll probably try to explain what it is. Probably it's the first time most of you have heard about a ROC. So a ROC is kind of a term we are trying to put together at Canonical and trying to popularize around containers. A ROC is a Docker image, full period. Now you ask me what's the difference. So we are calling ROCs things, containers, that follow a very specific design. Right? If you ever talk with someone and you are talking about containers and they mention a ROC, know that a ROC is Ubuntu-based. It's a container image that it is Ubuntu-based. It has a predictable and dedicated entry point. So all ROCs have the same entry point. If you are used to containers and Docker images, you know that when you start one, some application will run. In our case, we actually run an init system inside a container. And that init system will launch your application. We call this init system Pebble, pun intended. So these are some of the decisions that make a ROC what it is. So it's specifically about design and opinions that we have about containers and how we build those container images. So we also have a tool called ROC Craft that is used to build those containers, which is a declarative tool. It's an alternative to Docker files, and I'll show you that during our demo. So one of the reasons we are putting a lot of effort behind containers and especially trying to go one step beyond the current market offering of containers you would find on popular registries is because from certain predictions that we can find here in this study, we know that, or we predict that in about 5 years or so, most companies will be having some form of containerized workloads in their infrastructure, and probably a big chunk of their enterprise applications will be running inside a container. So we are kind of looking into this as what is the future of the Valkey as a container. And again, we are packaging, and we do have a prototype of Valkey as a ROC. And if you look at it, what you will see is that that container image has been built with that tool, ROCcraft, fully declarative. It's a YAML file that even the less technical people can understand. You can see what's going inside. It is Ubuntu-based. It will always be Ubuntu-based. You can have no base at all. You can say, as you would do for a Docker image, that I want a distro-like container image. You can do that, but you still build your bits and pieces in an Ubuntu system, in an Ubuntu build environment. There is the so-called Pebble entry point. That's what will manage the Valkey process running inside a container. If you are not familiar with init systems, in this case, this is a container-optimized init system that gives you advantages like reaping of zombie processes, service management, lifecycle management, log forwarding, and so on. There's also some additional metadata that we ship with the image because, believe it or not, I've been using containers for a long time, and one of the biggest no-brainers I always found to be a struggle for me is that I'm running an application inside a container, and from inside a container, I was not ever able to know even the name of the image I'm running on, which sounds silly to me. So one simple thing we are doing with ROCs is that every ROC has enough metadata inside that your application can use to infer the environment it's running on. Then also, when it comes to security, one of the major reasons why we are doing ROCs, we have a new concept called Chisel. I've been talking about it during the Open Source Summit, so maybe some of you have seen a demo around this, but Chisel is a tool which is embedded in ROCcraft, but you can also use standalone, that is used to slice Debian packages. So it works with the Ubuntu archives, with Ubuntu packages. And what it does is that for a container, if I want to reduce my attack surface and take everything out that I don't need for production, I can just tell Chisel, hey, give me that package, install it, as you would do with apt, for example, but leave out everything else but these specific paths, these specific files and contents. And this guarantees the same functionality while taking out everything else that you don't need, and therefore removing you from being exposed to vulnerabilities that you probably didn't know about. So it comes up as a very minimalistic image and also a very secure one. So what we have right now is a proof of concept. So for 2410 and 2404, you should expect the same version containerized there. The entry point services that we have running through our init system, the Pebble, are the Valkey server and the Redis exporter. This could change. It's still a POC, but this is what we have today and what I will show you in the demo. In terms of size, the POC has around 50 megabytes compressed, but the chiseled one, which is the thing I just talked about, without any utilities, without any base, just Valkey, the binaries, and all of its dependencies, sums up to around 11 megabytes compressed. This, to be honest, it needs some testing still. I'm expecting the size to go up a bit, but not nearly close to the non-chiseled size. So we will have this rock as small as possible. It might be above 11 megabytes, but you can expect it to still be much smaller than the non-chiseled one. So when it comes to deploying this to Kubernetes, there was another report here, a bit older, maybe a couple of years now, but still quite relevant in the sense that when surveying different organizations, we know that Ubuntu is the most used OS for Kubernetes nodes. And at Canonical, we have been trying to as well offer our own distribution of Kubernetes. We know that people actually are looking for one single distribution for multiple environments and not different factors of Kubernetes for different parts of the computing spectrum. So whether you are doing edge or whether you are doing distributed systems, we have the same offering there. And some of the things we are doing at Canonical with Kubernetes is that we are offering it with the same support commitments that you'd expect from any other software coming from the Ubuntu archive. So there's the LTS, there are multi-arch. You can also find certain things about compliance with regulatory standards like FIPS. So this is what I'm gonna do to install or to deploy the Valkey rock in my demo. I have my own microcates installed in my laptop. This is the coming demo that I will show here. And this is something you can install through a snap. So just snap install microcates and you can get a Kubernetes distribution running on your laptop. I will not show that part. I already have it running, but that's pretty much how you get the Canonical Kubernetes into your own workstation. Before I start the demo, I'm not sure how much time. I think I still have plenty of time. So if you want to ask questions now before the demo, anything you might want to ask, let's do it now. Otherwise, I'll just jump to the demo. Maybe not. OK. So let me guide you here through the demo. What I'm doing is that I am starting by building the rock. So again, I'm using Rockraft. On the left side, you can see the YAML recipe that is being used. So I'm packing Valkey 7. You see that I'm actually packing Valkey 7 on top of Ubuntu 2204, which seems odd because we only have it Valkey for 2410. But I'm doing this because we're actually installing the snap. We are making a rock out of a snap, which is cool because you can interchange and combine different types of artifacts to build your own container. I have two services, as mentioned before, for this Valkey rock. One is Valkey itself, the other one is the exporter. You can see how they run and who's running it. So we have a specific user for running the Valkey server, which is being created down there in the second part. Part is a crafting concept that we have where you can build your own subsets of software to be packed into the container separately, and Rockraft will take care of it by itself. So on the right side, we have the .rock file, which is an OCI compliant archive that then we can export to either a runtime or a registry. So here I'm exporting it to the Docker daemon on my laptop. And I can give it a quick try. I can just Docker run it very quickly and instruct my Pebble entry point to just run the CLI and try to get something out of it. So just to make sure there is the Valkey CLI inside and it's properly running. So that seems to be working fine. What I'm going to do now is I'm going to start, I'm also going to show you a few things about the init entry point. So you actually can inspect the container without having to run Valkey services or anything. This is, again, thanks to the payable entry point. I can see what services I have. I can see how those services are defined. And now before deploying it to the microcades installation I have on my laptop, I have a manifest file on the right side. You can see that I'll be using the Valkey rock. I have a Valkey service. These are the arguments I'll be passing to the Valkey container image. And I also have a port mapping on the top using the node port. So first what I'll do, because I need to make my local microcades aware of the newly built Valkey rock, I'm going to save it as a tarball and import it into the microcades image registry that is local to my laptop. You wouldn't need to do this if you would just publish it to Docker Hub, for example. You could just get it from there, but since I don't want to publish it anywhere for now, I'm just doing this step first. So you can get it there now. It seems to be there. It has the decompressed size that we talked about in the previous slides. Now, I'm going to apply the manifest here, which is going to create a deployment with that service, I think a config map as well, and the pod with a Valkey container. So we can see the pod running there. There's also a service. And now I'm going to do the same exercise as I did before, just to make sure that I can run the same CLI info command I did with Docker, but this time using the pod that is running on my microcades instance. So everything seems okay there. So to finalize the test, I'm going to do something else that I just found was probably a cool exercise, is that I am going to create another rock, which is a Python client, a Python rock, that is going to use the Valkey asyncio module to work as both a publisher and a subscriber to the Valkey server running in microcades. So I have this separate other project. Again, it's a Python project. You can see that there is a rockcraft YAML. It's another recipe for another rock that I'm going to build. This one is a chiseled one because I have no base, so there is no Ubuntu utilities inside this rock, and there is Python 3.10 being installed with an underscore standard, something you probably never seen before. That's our chiseling convention. If you have an underscore after the package, that means that you are requesting a slice, not the whole package. So I have built this image before. You can see it there. It's 70-something megabytes decompressed. That's mostly Python and my scripts and dependencies. So what I'm going to run on the left side, I'm going to start this new rock, my custom Python rock with Docker on my own laptop. And I'm just showing you the services that are available there. It's just a Valkey client, so nothing too special there. I'm going to run it on the same network as my host, just so I can get an easy out-of-the-box access to the node port that is running the Valkey server. And I'm going to instruct my rock that I want to pass additional comments to my Valkey client service. So I'm going to tell that I want it to be aware of the node port where Valkey server is running, which is 30,001. And I'm going to tell this left side to run as a subscriber. So now my service will start. It's running in verbose mode, so we'll see a few logs there, and now it's waiting. All right? So this is subscribed to the Valkey server running in microcades. And on the right side, I'm going to do the same thing. I'm basically going to run the same container, again with Docker, on my laptop as well, again running on the host network. And this one I'm going to run it in interactive mode because I'm going to instruct the container itself to actually just execute my Python script directly, my Python module there, and run it for the same port, but this time to run it in as a publisher, basically, so -t pub there. So once this starts, what I can do now is just, as you would expect, a very simple demo. I can just send messages from one side to the other, and they are flowing through the Valkey server, which is deployed on the microcades cluster in my laptop. So that's a very simple standalone demo, just making use of the Python Valkey client, 3 different rocks, one of them deployed in microcades, and the other 2 just on my laptop. And that's just, I think, pretty much it. If you have any questions, just let me know. Otherwise, you can find me elsewhere. outside this presentation and outside this room. So yeah, thank you.